Swayam Prabha. Digital India. Educated India.
Welcome everyone. My name is Gaurav Bhaumik. I'm from the Agriculture and Food Engineering Department of IIT Kharagpur. So welcome to this NPTEL online certification course on advanced aquaculture technology. Today we'll start the module 4 on technology of crustacea farming on the lecture 1 of introduction to the freshwater prawn culture. The topics that I'll be covered is the introduction to the crustaceans, general characteristics of them, freshwater prawn culture, diseases, and the control measure for this general prawn in case of prawn cultures and all. So in general, the crustaceans are a part of phylum arthropods, right? So in general, the species like crabs, prawns, lobsters, barnacles, crayfish, shrimp, beach fleas, krill, and woodlices are the ones which are considered under this category and this crustaceans category. And then these are the ones which we normally people like we farm and we use it for different purposes. They are actually the most valuable and the most highly traded seafood commodity out of all the available market that is like there in the aquaculture industry. It contributes to around 8% of total fish supply worldwide, almost 14.5 million tons per year. Okay, the world crustacean culture, it involves almost 70.6% marine and 29.4% freshwater production. In Asia itself, actually the China and Thailand specifically, they are the major producers, almost 75% of the crustaceans in the world. Surprisingly, you will be astonished to know that these crustaceans are responsible for 94% of the estimated increase in the carbon emission from fishery sector. So it has this good part as well as the bad part, like cons and pros is there. So the pros part is that it's a major source of seafood supply for the most of the part of the world. However, it comes with a huge amount of cons part, huge amount of disadvantage of becoming the major carbon producer, right? Carbon producer, carbon emitter in the world. So that's why we like the farming process itself. So that's why we need to adhere to, or we need to start thinking about actually the technologies are already available by the researchers, by the scientists. We need to go and ask them. We need to search for the available optimal design of the farm so that these carbon emissions can be minimized. They have actually some direct and indirect benefits on the human health, like in terms of aesthetic value, this hermit crabs, this mantis banana shrimps, this blue lobsters, this attade shrimps. You see the attade shrimps, one example of how it looks like. So they are often used for the aquatic exhibitions, or they are very rare and they looks very nice actually. So that they look very nice. So that's why we put it in the aquarium and marine aquarium and for aquatic aesthetic enhancement. Commercial wise, the crabs, shrimps and the lobsters, they have the highest commercial value among all the other crustaceans. They are the very rich source of protein and comparatively much costlier than other sources of animal protein. However, this is like very much sought after products in this particular sector, in aquaculture sectors. Giant tiger prawn and the Pacific white shrimps are among the most cultivated shrimp species. It accounts for almost 80% of the total cultivated shrimp species. Giant tiger prawn and the Pacific white shrimps. Okay. So in biomedical value, the shells of crustaceans, the crabs, they are used for treating the inflammatory disease like inflammatory bowel diseases and all. Okay, so it has a medicinal purposes also, medicinal utilizations as well. It used as a bioindicators. What do I mean by the bioindicators? It can indicate the environmental degradation. Okay, if the water is polluted or not, that we can easily identify if we go for culturing the ghost shrimps. So we scientific name is Palamonetis argentina. So this P. argentinus, this also known as ghost shrimp or the feeder shrimps, is an indicator of the environmental pollution or the amount of pollutants present in the freshwater nature. So that is what we call as bioindicators. Okay. Geological point of view, ostracods or the seed shrimps, okay, so they are the most common arthropods found in the fossil records. So based on that also we can have an idea about the evolutionary point of view, how like in terms of for it's a big of a thing for the scientists who are working with the fossils and all. Okay. So other uses, the mole crab or the sand flea are used for bait in the game fishing. I think you know what is game fishing, or so this is game fishing is like, you'll have a competition of game. So it is like very famous in different parts of world where people go for recreational fishing. So recreational fishing is like one when there is like already cultured species are available, you go for fishing there, and the amount of fish that you can harvest, based on that you will be given a prize or something like that. So it's a game fishing. It's a kind of recreational activity. It's there in all over the world in different places. You will find this kind of culture. So there, as a bait, we use this sand flea or this mole crab. So this is the crustaceans that we normally use as a bait for the other fish species to collect, for the game fishing, sports fishing also we call it. What are the general characteristics of crustaceans? They have a very hard skin, or we call it shells, because of the calcium carbonate deposits in the cuticle region. So because of that, the calcium carbonate layer it's that hard in structure. It either they breathes through their gills or through the entire surface of the body, based on the type of species that we're culturing. Crustaceans, they excrete through the antenna or the maxilla gland. They have an open circulatory systems, and their bodies are divided into mainly the three segments. First, the head or the cephalon, the thorax, and the neck part, and the abdomen or the pleon part. Okay. So freshwater prawn culture, the practice of freshwater prawn culture is thriving because it is more useful than catching them from the rivers, canals, lakes, estuaries, or the streams, because it's sometimes nowadays it's started depleting even in the natural resources. So because of that, the freshwater prawn culture is becoming a very big of an industry in all over the world. So it grows very fast. Actually, within 6 months, it comes to its mature stage, or the marketable size of 150 to 180 millimeter, and around 1.4 million hectares of Indian estuaries and backwaters are suitable for prawn farming, but it is not being utilized fully. Okay, so there are ample amount of opportunities lie with this particular sector, the freshwater prawn culture in Indian scenario, and definitely there is a possibility of designing in a proper farm, so that we can get a maximum benefit as well, in the economic benefit as well, considering the environmental benignness. Okay. Macrobrachium rosenbergi, or the scampi, is the very most preferred commercial species available in India, and not only India, like in the India and Southeastern Asia also. It's a giant freshwater prawn, we call it. So the scampi hatcheries are the one which is very famous, and we in India also we have different organizations who are working on it, and they have developed different methods, and they have developed a very nice design of those hatchery farms, which are optimal in nature, which consider all the environmental benefits, which consider all the economic benefits, and that is already available. So it just need to be popularized right now, so to have a more amount of farms in future to have in India, so to provide the ample amount of shrimp to all over the all the market that is available in India. Not only in India, but also it can start exporting to the outside India. So because there is a huge market lying outside India, especially in Europe region. So the size of this Macrobrachium rosenbergi or the scampi varies from 150 to 250 millimeter. Maximum size can be 320 millimeter, which is really huge. They are usually we can find them in the extremely turbid conditions, and they are also known as golda chingri or mocha chingri in India. If you see their life cycle, so in general they are incubated, the eggs are incubated for 21 to 25 days by the female. They kind of carry it. Then this Joya stage, where it's like 5 to 12 instars in like 20 to 40 days, they have different stages of development. Then there comes this post larva or the juvenile stage, where from this juvenile to adult it will take 120 to 210 days for them to mature, come to the marketable size. So which is like altogether, it's like if you calculate like altogether, it doesn't take more than 180 days, which is like around 6 months of time. Okay. So the major producers of the Macrobrachium rosenbergi are, if you can see, it's like China, Taiwan are the one which is like majoring. The province of China, Bangladesh, Ecuador, India, Brazil, Malaysia and Thailand are the one who are leading in this sector. Okay. The steps in freshwater prawn culture, when we try to design a freshwater prawn culture or the hatcheries, we need to think about certain parameters which are very important. Okay. So first of all, to start with is the site selection. Climatic condition is very important for, like, it's one of the major consideration for the site selection. Tropical or subtropical climate is like most suitable for long culture period. Warm climate suitable for short culture period. Like if you go ahead with the temperate region and then further in the polar regions, it has to be very, you have to be very precise that that's not a standard site for the production of the freshwater prawn and all, but you can do it. There are possibility and there are people doing it right now. So they are trying to mimic the this environmental condition in a controlled environment, in a controlled atmosphere, in a greenhouse and all. Topography, the flat and the gently sloped land is needed. Soil quality, the recommended is the sandy loam soil containing 60% of the sand and 40% of the silt with 85% of water retention capacity at least. Okay. The clay content cannot be more than 60%. Okay. The soil with the acid sulfate should be avoided, so to have a harmful impact on your product. Water quality, definitely unpolluted water. What does that mean? Like it shouldn't have any kind of pollutions with, it can be all the organic species, it can be inorganic species, it can be metal contamination, it can be thermal pollution, it can be radioactive pollution. You need to think about all these pollutants in your system. You have to take the water first, check it in the water quality lab and check that all the parameters are well within the limit or not. If it is not, then you have to treat that water before going for, or you have to go for the freshwater exchange. It can be seawater, it can be brackish water exchange. Okay, so to have a proper quality maintained in your farm. Okay, so the pH has to be well within 7 to 8.5, the temperature 18 to 34 degrees Celsius, dissolved oxygen 3 to 7 ppm, hardness of around 550 to 100 milligram per liter of calcium carbonate. So that has to be maintained. It's just to have a proper quality of water for the supply of for the production of your crustacea or the target, whatever the target like prawn you have. So the pond construction size and depth, area should be around 1 to 5 hectare to have a maximum economic benefit actually. Square farms are more economical in terms of the easy to netting and all, and rectangular farms are more appropriate for harvesting in that sense, and capacity should hold at least 1.5 to 2 meter of water inside. And the dike, the drainage point and the dike that you have to maintain, the bottom needs to be sloped towards the dike, and mixing of the outlet water and the incoming water should be prevented. What does that mean? The dike has to be maintained as the end, so the slope when it ends, so there will be like outline outward pipe from where the drainage water will go out, outlet water. So this outlet water cannot be in touch with the incoming water which is coming from the other side. It has to be coming from the other side. You have to design it accordingly. Okay. Water supply 15 days after the liming. So what do I need? Why do I need liming? Liming is a phenomenon. Liming is a method that we normally use to get rid of, to prepare the land. It's very important. It has a drastic influence in the pond ecosystem. So I am not going into details what is the purpose and all, because I can take a full lecture on this liming material, the usefulness of liming material in pond, before pond construction, and even after the pond also we provide it sometimes. But what are the reason behind it? You can better search for it in Google, and what is the requirement of liming and what is the need of liming in the pond development and all. Okay. The pond should be filled slowly to facilitate the oxygenation. Okay, so slowly you have to fill so that it will get much time to for diffused oxygen from the air to come in contact with the water, and it will enhance the oxygenation or the oxygen content in the dissolved oxygen content in the water. Preferred source is obviously the groundwater and the clean canal water. Incoming water should be filtered using the 300 to 100 micron mesh fabrics to remove all the unwanted predators and all. The drainage system you have to design, it should facilitate the effective removal of all the water and the subsequent drying of the pond. Okay. Mainly the drainage system should be done, drainage should be done by gravity or by pumps, preferably via a monk structure or a sluice gate structure. Okay, so monk is a civil, it's a construction term which we use in the, like, I'll discuss it in details in the later lectures, so how to design this sluice gate for tight fed farms and all. The outlet water must be checked to avoid the fish escape, so you can put a net material which has the mesh size lower than the minimum size of the fish that is dwelling in your farm. This is the standard structure of the production cycle of Macrobacterium rosenbergi. If you see, it starts from the buried females, which obtained from the captive broodstocks. You see from them the larva obtained from the egg carrying buried. You see, the first is the broodstock. Okay, broodstock. From the broodstock we have this buried females. From these buried females they produce this. They have these eggs. They produce then egg carrying females. They provide the egg is hatched and the larva is provided. Larva is obtained. This larva it paired in the 11 larval stage to metamorphosis to the post larval situation. For it will take 16 to 35 days in a hatchery tank. From there it comes to the recirculating systems with the flow through or the recirculatory systems, and it comes to the post larval pond, and this post larval pond to the nursery tank or the earthen nursery tank for the further growth of the juvenile stage, and then they shifted to the grower from pond, where they with time they will become mature and they are harvested either sold in live, fresh, on ice or frozen conditions. So that's the production cycle of Macrobacterium rosenbergi it looks like. So the broodstock can be collected from the prawn that is harvested or from the capture fisheries, also from the wild habitat. The production systems, the fertilization. So the broodstock, it's actually the female prawn which found in the tropical freshwater, where the adult prawns are present in all around the year. So in general we use this broodstock obtained from this captured fisheries, so the grow out pond, for the external fertilization process. The fertilized eggs subsequently get attached to the hairs of the pleopods of these females, as you can see from the figure how it looks like until the eggs hatch. So up to 4,000 eggs can be carried by each these buried females for about 4 months. Can you imagine? Like, and then these eggs are orange in general. Okay, so until the 2-3 days before hatching. At the end they will almost, if you see the color change in the right side, if it's like this more orangish in color, in the left side it's a grayish black, so that means it's about to hatch. Okay, so larval development after it's hatched, so it's called the zoe stage. So then the zoea stage, the zoea stage, in the free swimming zoea is produced after the hatching of egg. The zoea grows from like 2 millimeter in the first stage to almost 8 millimeter at the end of the metamorphosis. What is their natural food? What is their food? They, in general, they go for the trash fish, broken rice, vegetables, tapioca root, agriculture, animal husbandry byproducts for enhanced growth rates and the quality. The feed is provided in pellet form and must stay intact in underwater for a few hours until consumed. Recently, the trend has changed also. Recently, people are, as we discussed in earlier lecture series, that we go for live feed as well. So nowadays even artemias are used. This artemia or this brine shrimps are used for their consumption as well. Okay, so their eggs are actually used there. We culture these artemias and they are being used for as a feed for the larval feed as well. The harvesting is done either partially or completely, as giant prawns do not grow at a uniform rate. So we harvest it only the one which is already matured enough, and we leave it back. The others with the bycatch, bycatch, you cannot call it bycatch. Like the one which is not mature, we just leave it back to the system so that they will grow. And once they will grow and in the mature stage, then only we'll take it out of the pond or the tank or the target production farm. So the larger prawns are actually separated during the partial harvesting using the special nets of mesh size of around 3.8 to 5 centimeter. Whereas 1.8 centimeter mesh size nets are used to separate the smaller prawns. Okay, so complete harvesting of prawns can be done by draining the pond. So once you know that it's complete mature stages already attained by all the shrimps, so you completely drain the pond and you collect all the shrimps. Okay, to avoid the overheating of the water, draining is usually done early in the morning. So we drain the water, we go for the freshwater exchange early in the morning. So at that time, the overheating problem is not there, especially in the summer season. Especially we go for this tropical and subtropical region, there is a chances of overheating because of the sunlight, the maximum amount of sunlight present in this time. So the prawns are provided with the fresh oxygenated water where they are near to the outlet, and this freshwater prawns should be handled carefully during the harvesting, otherwise they can turn mushy. Okay, so if prawns are sold live, they can be transported at 22 degrees Celsius aerated water. Sometimes, and if it is like frozen or air condition, we can have a proper ice chambers, or what is it called, this cold storage vans and all. Okay, they should be killed in a mixture of ice and water at 0 degrees Celsius, followed by washing in chlorinated tap water. If they are not going to be sold live. Why they should be killed in mixture of ice and water in 0 degrees Celsius? It's like thermal. It's a kind of a shock. Okay, hypothermal shock. So these hypothermal shocks are needed for kind of less cruel way of killing them, and it can make them in an intact condition. They're almost intact conditions before they're being consumed by human consumption or maybe for any other uses. Okay, prawns must be kept for more than 3 days on ice if they are going to be sold fresh, and the prawns, if intended to be sold frozen, should be frozen quickly at 20 degrees Celsius, at minus 10 degrees Celsius, followed by storage at minus 20 degrees Celsius or below. Okay, for its maximum to retain its authenticity, the maximum, like their taste and all. Okay, so diseases, and what are the diseases that can normally happen in case of this freshwater prawn on Macrobrachium rosenbergi, and what are the troubleshooting measures that we can obtain. So this is the chart. It's like it's taken from the FAO's standard procedures that is kind of experienced, or like all over the world. People are using this chart for all over the world. This particular, I'm giving you one example, the MMV, Macrobrachium muscle virus. So which is like, agent is like parvo-like virus, the type of the living organism is virus, and the syndrome is infected tissue becomes opaque and with progressive necrosis and affects the juveniles as well. So protective measure is they improve the husbandry. Okay, improved husbandry means try to improve the farming practices and all of this. So and try to get them separate them in a quarantine pond and do something, separate the quarantine pond and try to improve the quality of the husbandry. That's the basic thing that you can do. In case of say like bacterial necrosis, like Pseudomonas or Leukothritis, so they are the bacterial in nature. They are in like living organisms which are responsible for that is bacteria, which is similar to the black spot but only affects the larva, especially stages 4 and 5. In that case, not only animal husbandry will fulfill the situation, but also you have to supply it with some chemicals, supply with some pharmaceuticals like the nifurpurinol and etc. etc. So these are the one, penicillin, streptomycins and all. So these are the one which will help them to get rid of, it's like a kind of medicine for them to or the measures, that control measures that we can take while they will be affected by these particular diseases. I'm not going into details for each and every diseases. It's actually available in online. You can definitely search for it. You can have a better idea about what type of agent and what type of syndromes are actually present and which can cause that specific type of disease, and what are the measures that can be taken. So once you will do the farming practices, you have to have this chart ready with you. You have to have this chart or table ready with you. So once you will see those syndromes which are written here, if you see those syndromes in your farming species or farming whatever you say, the target species, what you need to do, you just first thing you just go ahead with the initial measures, go for improved husbandry, or you go for, and definitely parallelly you go and talk to the experts and talk to the veterinary experts who knows more in details about these diseases and how the syndromes are actually caused by that particular disease or some other. Then they will suggest you the measure that you need to take, the amount of what are the chemicals that you need to provide them, so to get rid of that particular type of microorganisms. So that is the way that we need to go ahead. Okay. So there are other diseases as well, a lot of them. I'm not going into details. Like it can be the type, you can see that the type of microorganism responsible for it can vary a lot. It can be viral, it can be bacterial, it can be fungal, it can be protozoan, and there are some unknown organisms which are also involved with it, like idiopathic muscle necrosis. It's an environmental disease, it's called. Why the type of species is still unknown, while still under process. There are different how to say suggestions or different expressions by the researchers, and they say simply we should go for the hatchery disinfection and the dietary enrichment or the improvement in the hatchery, improvement in the husbandry. So that's one of the major correcting mechanism that you can go before for this kind of disease elimination. So the reason behind the several diseases are majorly the poor treatment of the incoming water. The fresh water that is coming, it has to be properly treated. That's why RAS systems have started becoming a very famous RAS system, recirculating aquaculture system. The water, because it needs a very frequent freshwater exchange, right? It can be, the water exchange is very frequent. So what you need to do, whatever water that is coming out of this plant, of this farm or this tank, what you need to do, you can have a proper recirculating aquaculture systems which will treat that wastewater, and the water after being treated, that water can be again circulated back to the pond itself. So the treatment problem can be minimized, treatment problem can be properly controlled by having this kind of recirculating aquaculture systems. Poor husbandry, definitely it's a big of an issue, like overcrowding or the higher stocking density, poor sanitation. If you do not have the proper cleanliness is maintained there, and there is dirt particles here and there, it can cause a huge amount of nuisance in your farm. Non-existent or insufficient quarantine procedures. I told you, the moment you get to know about the disease or disease causing particular particular species, you have to shift them now and then, that moment only, because they can spread very fast in this kind of species. microorganisms which are causing this disease causing microorganisms, they can spread very fast. So the moment you identify no matter what, you just simply catch them and shift it to the quarantine pond, and then you do the next stage of troubleshooting. That's the first thing that you need to do. Okay. So what are the conclusions from whatever we have discussed in this particular lecture? That the crustaceans are most valuable and the highly traded seafood commodity. Most crustaceans culture involve 76% of this world crustacean culture, it involves almost 70.6% of the marine and 29.4% of the freshwater production. Asia is the major producer of the crustaceans, and the Macrobrachium rosenbergi, or the scampi, is a giant freshwater prawn and is one of the most preferred commercial species in India and specifically in Asian region. Major producer of this scampi are China, Taiwan, province of China, Bangladesh, Ecuador, India, Brazil, Malaysia, Thailand, etc. And like these countries, like mostly the Asian countries. What are the takeaways? Crustaceans are the most valuable and the highly traded seafood commodity. The Golda chingri or the mocha chingri, which are actually more famous in India, like with these names rather than the scampi, is the most preferred commercial species in India. Tropical, subtropical and the warm climates are the most suitable climate for the prawn culture if you want to do it in the temperate region, if you want to do it in the polar region, if you're going to like more in the polar side. So like whether it be north, whether it be south, you have to take care of the environment. You have to focus more on the optimal condition that you can supply for your greenhouse, so that, or you mean like you have to maintain that situation, you understand, right? You have to provide a heating arrangement so the temperature will be optimum for them to grow in the system. It's a lot of activity, but it is doable and it is being done it's being done in different Scandinavian countries and all. Okay. Then the external fertilization occur, sometimes it requires in freshwater prawns. Giant prawns are harvested either partially or completely, as they do not grow at a uniform rate, and it has to be handled very carefully during harvesting as they tend to turn mushy. Okay. This Macrobrachium rosenbergi is affected by several diseases, which is the reason behind because of the poor treatment of incoming water, overcrowding, poor husbandry and sanitation, and insufficient quarantine procedures available in the farm. I hope this discussion in this lecture will definitely enlighten you with the standard practices for freshwater prawn. So though I cannot go in details with the detail engineering discussion and all, how to design and what will be the detailed the technical concerns and all, for that you can go ahead with the references that is available here, or if you have any issues, so you can mail it to me. I'll be very happy to give you a detailed lecture material, or I can share you my lecture material from my regular classes in IIT Kharagpur. So that will give you some better idea about how to design these farms in general. Okay. So that's it for this lecture. See you in the next lecture. Thank you so much.